Alright, okay. So we ended yesterday kind of talking about some of the transformations. We know that if something is added onto the end, it made our graph go up. If it was subtracted from the end, it would go down. If something was added on the inside, it moved to the left. And if it was subtracted on the inside, it moved to the right. So now, let's look at number 10. You might be able to tell me a couple things. What should the minus 4 do? Well, the minus 4 is attached to the x, so it'll move it to the right 4. And the plus 1 on the end would move it up 1. But we have another thing on this. We have that negative. So let's see what happens. Our vertex. What's the x value of the vertex? 4. It's kind of like saying what makes the inside of this parenthesis 0. Okay, it's just a 4. And the y value is 1. How do we get the rest of our points? Put it in our calculator. So go to your y equals, put in your equation, and then go to your table. All right, so when we put in a 2, when we put in a 3, we get, sorry, what did you say? Okay, so when you put in 2, you got, and when you put in 3, you got, and when you put in 5, you got, when you put in 6, you got. So we have 2, negative 3, 3, 0, 4, 1, 5, 0, 6, negative 3. So did my graph move to the right 4 like we said? Yeah, did it move up 1? What else did it do? It flipped upside down. How do we know that that parabola is going to be upside down at the beginning? The negative on the x squared tells us it will be an upside down parabola. So this one has a flip, right 4 and up 1. All right. Let's look at this. This one has something else going on that we haven't seen before. What is it? We have the minus 7 should do what to our graph? Down 7. But we don't really know what happens when we multiply our x squared with a 3. So we need to figure it out. The vertex. Okay, if you're looking at this x squared, there's nothing added or subtracted, so what's the x value of our vertex? 0. Okay, what do we get for the y? Negative 7. Okay, now use your table. So when we put in negative 2, and everybody should be doing this, when we put in negative 2, what do we get? We put in negative 1, we get 0 gives us negative 7, 1 gives us, and 2 gives us 5. You'll notice, could you look at a table and pick out your vertex just by looking at that table? How would you find it? Yeah, Yeah, when things start repeating, you notice it's the same on both sides of those, so you can kind of see the pattern and check your vertex on the table too. All right, so if I plot those, I have -2, 5. One thing, I was looking at papers just from yesterday. Make sure when you graph these, what shape are they supposed to be? Is it a V? No, it's curved. It's like a U. So if you're one of those people drawing a V, please start curving it a little more. All right, so if I look at this one, did it move left or right at all? No. Did it move down 7 like we said? Yes. What else happened? How did the shape of it change? Yeah, it got taller and skinnier, right? Think of it as kind of like if I have a rubber band here, okay? So this is my parabola to start with. When I take it times 3, it's like taking your height times 3. As I stretch it up, what's happening to the width of it? It gets skinny. It's getting taller and skinnier. So that multiplying by 3 is a stretch. It causes our graph to stretch, or vertical stretch, so it's getting skinnier and taller. Like if you take something and stretch it out, it gets tall and skinny. You could say a stretch by 3 if you wanted to attach a number to it. Just means we're multiplying our height times 3. One more. Tell me all the transformations you know from what we've done so far. What would a negative in front do? Flip, so it'll be upside down. Okay, what would the -3 on the x do? Inside is x, so it's moving left or right. When you add to the x, you go to the left, so subtracting moves it to the right. What would the -2 do? Here's a little, if you add 2x, go to the left. If you add to y, go higher. Okay, so if you add to x, you move it to the left. Add to the y, it goes up high. So the opposite would move it down or right. Okay.
The x and the y like to start off with.
My vertex, is that what you're talking about? So remember our vertex form from yesterday. Our vertex was the order pair HK. So H is really a couple ways to think of it. One way is just what makes this equal 0. So what makes x minus 3 equal 0? Positive 3. And then the k is just what you added on the end, which this was a -2, so my y is -2. So that will be my vertex. Use your calculator to get the other points. When you put in 1, what do we get? -4. 2 gives us 3, -2. 4 gives us, and 5 gives us, let's find 1, -4, 2, -2.5, negative 2.5, 5, negative 4. So a little bit hard to tell what that 1/2 is doing from this. We definitely moved right and down, we flipped. The 1/2, so if you have, something and you are stretching it out, if you take your height times 1/2, when I smush it down, what's going to happen to it? Yeah, it gets shorter and fatter. So this is like shrinking it. You push it down, it's going to get short and fat because I took my height times 1/2. So basically, if it's bigger than 1, it'll stretch it so it'll get skinnier. If it's between 0 and 1, so it's less than a full parabola, it's going to shrink it and it'll get shorter and fatter. And we usually call that a compression. So it's just like taking your height times 1/2, so it compresses it. So let's kind of summarize what we've done. When we have something in vertex form, all right, H is the horizontal shift. Tells us how we're moving, it's attached to the x, it tells us how we move along the x-axis. If it's adding, so if you add to x, you go to the left. So that means if you subtract, you would go to the right. K is on the end, so it's changing our y. So that's what's called the vertical shift. Okay, if you add to the y, it moves it up high. So if you're adding, it goes up, subtracting goes down. All right. If you have a negative, then we can say it is flipped or reflected, whichever word you like, across the x-axis. It just makes it get upside down. Okay, if your A is bigger than 1, it will stretch the graph. If A is between 0 and 1, it will shrink or compress our graph. So what we're going to do now is use this knowledge to write equations. Okay, our parent function is x squared. If I want to write an equation that would be translated 2 units to the right. Okay, so the first question is, if you're moving left and right, is it attached to the x or is it outside? Attached to the x. If you're moving along the x-axis, left to right, it has to be inside with the x. So I said, if you add the x, it goes to the left. So in order to move to the right, we would subtract 2. If you wanted to check yourself, what could you do? Yeah, could we graph them? Do me a favor, go to your graphing calculator. Go to your y equals. Here's what I want you to do. I want you to type in x squared, and then go down and we're going to put in a second equation. We're going to do x minus 2 squared. This way we can clearly see the difference between the two. So my y1 I did x squared, y2 I did the x minus 2 squared, the equation we just wrote. If I look at the graph, yours isn't in color, but the first one is the original. Did the second one move it to the right too? Yeah, so we have the right equation. We could check ourselves out. Okay, let's look at the next one. If I want to move up where do we put it? Outside. So the x squared doesn't change. If we want to go up, we would add 5. If I wanted to check myself, I could go to my y equals, leave the first one the same, make the second one x squared plus 5. I can see, okay, there's where I started, there's where I ended. It went up 5. So you can look at your graphs to double check. All right, 15. 3 units to the left. So what makes it move to the left? You have to put it with the x, add to x, go to the left, so it'd be x plus 3 squared. And 4 units down, what would make it go down? Minus 4. Let's look at 17. Reflected over the x-axis. What makes it flip? A negative in front. Then translated 3 units down. What makes it go down? Minus 3 on the outside. Vertically compressed by a factor of 1/3. Whether we're compressing or shrinking, that's just multiplying it by the 1/3. So we have a 1/3 x squared, and then it goes up 8, so we would plus 8. I want you guys to try 16, 18, and 20. Okay, so what would make it go right 7? And up 4? Looks like we did pretty well on that one. 18, reflect over the x, so that means, okay, going right 5 and 2 down. And the last one, vertically stretch by a factor of 2. Means we multiply by 2. Reflect over the x, so what does this have in front of it? And then translated 4 to the left, so be an x plus 4 squared. Any questions on those? So here's what we're doing. I have, if you got done in class yesterday, I have your papers from yesterday. You need to finish it. You also need to go back. On the front side, I told you you could skip writing the transformation yesterday. Some of you went ahead and did it. If you didn't, you need to go back and add in what the transformation is. And I marked if you had anything wrong, so if you made any mistakes yesterday, fix that. So finish, add your transformations, fix any mistakes.